This is Algebra 1, Semester 2. It's the 4th unit called Exponential Functions. It's the 5th lesson called Rules of Logs Practice. It's from CreatorMathcom under the Algebra tab, and you might have to Google CreatorMath.weebly.com to find it. Copy the following problems 1 through 10 into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So just to model that, what do these notes look like? Because we are going to use them extensively for this lesson. So let's go here and let's go back. Okay, maybe not. There we go. So here's where you're headed. CreatorMath.weebly.com. Type that into Google. You should be able to find the website. Here's what the home page looks like. All of the composition book stuff is on this homepage. Scroll down until you see the picture of the comp book and the big words comp book, and see everything under it. Watch all the videos and do all the requirements. Otherwise, if we need notes, we're going to go over to Algebra 1. These are the vocabulary. This is a PDF right here with all the vocabulary on for the whole year. You're going to find all the answers to all the vocabulary practices on that document. Scroll down past this. Let's go down to Semester 2. Let's find the right unit. And it's unit, there it is, we passed by it, exponential functions, and it looks like we are on lesson number 5. So this is way down here, lesson number 5. Oh, actually it says this, but I'll make sure that's fixed up. Here are the pages it goes on in your comp book. Don't trust this table of contents, but please go find the original table of contents, not on this video, but this one here on the website. And then notes, let's click notes. Fair warning, you might have to load it a couple times. I do sometimes. That one loaded right away, so for whatever reason my internet is working well. This lesson is on, this is Algebra 1, so covering logs in Algebra 1 is a little bit of a stretch, but we want to kind of prep you for Algebra 2 to kind of just get you the idea of hearing the word logs, understanding there's certain properties we can use with logs, and getting you to practice a tiny bit with those. So this is going to be called Logs Light, all right? So go back through the notes, put these into your comp book on the correct pages. It explains to you definitions of what are logs. Sometimes that definition doesn't always help students. Nonetheless, we can use them to manipulate different statements, and we're going to practice those here a little bit. The simple definition of a logarithmic is having a base raised to a power which is a variable. That's probably a simplistic understanding of it, right? So there's a base. The x in the x to the power 2. This is a base. Power, the 2 in the power 2, right? So we're going back over what's a base, what's a power. In this case, for the exponential function, the power is a variable. So we have x raised to the power, 2 raised to the power x, right? And it equals 6 in this case, which looks like a b, but it's a 6. So we're going to keep these notes handy, and especially these right here. They're going to run us through this practice, and let's see what we've got here. In fact, let's keep them right up front and center. So this says, complete the following logarithmic rule. This is conditions of the log, where b is greater than 1, and m, n, and k can be any real numbers, and m and n are positive. So that sets up the basis for what they're giving us here. But what we need to look at is this right here. This is pronounced log base b with m times n, or of n times n. So these could be numbers or variables, in this case probably numbers, and then we have certain things we can manipulate in terms of the properties of logs, and we're going to look straight at the notes and see this list. So what we have here, if we have a log base b and m times n, we can convert that to log base b m plus log base b n. And this is just a rule of how logs work. So part of you is just trying to practice this, possibly without understanding too much. And that's always one of the things in education we're trying to not necessarily avoid, but just warn students about. At some point we're going to practice a little bit of this, and other times we're going to go back and try to explain to you more on an intuitive level what a log is. And if I had to say that off the top of my head, maybe the easiest thing to imagine is a log is an expanding scale representing a curve that is exponential. So what is an exponential curve? A curve that represents, say, the spread of a virus in people. One person gets sick. They get 2 people sick, right? Each of those people that are now sick get 2 more sick. And each of those people that are now sick get 2 more people sick. What happens is that the curve, right, it starts out like this. Let's get a little graphic going. The curve is some people are sick, not many, but all of a sudden the curve goes, wow, it explodes up. Everybody's sick. And what happens is through these portions, we're not increasing at a rate that's consistent. We are increasing at an ever-expanding rate. So a log helps us deal with those kind of situations where the rate that we're expanding at is now multiplying by itself. It's an expansion of an expansion. Like in physics, like in acceleration, right? An increasing of speed. So this isn't real technical explanation of a log, but maybe it helps you understand a little bit of an ever-expanding situation. So with that said, let's go back and try to just follow what they're saying. If this is this case, log base b, m times n, is equal to log base b m plus log base b n, I'm just going to go ahead and I'm going to circle the correct answer here. And I'm going to note that it's multiplied on one side of the equal sign, but once we split it apart like this, we can add it. And that's the effect we're going to have, and that's what we're going to see as we roll through these. Here's the next one, log base b of m divided by n. Right? Let's check our notes for that. So here we have a log base b of m divided by n equals log base b m minus log base b n. All right? So we're looking for this one here. We're a special note on this subtraction there, and of interest to us that this shifts from a division on one side of the equals to a minus between the 2 statements on the other. And these are properties of logs, so part of us goes, that's interesting, and that's kind of what we're going for in this log light presentation, right? So a log base b of m to the caret k, let's check our notes with this. Log base b m to the caret k is the k gets to come out front and be multiplied by the log base b m. So this k comes out front and the log base b m remains. So we have k times this log base b m. Right? Let's see number 4, and they're just walking us through these one at a time. Notice that the actual practice set is in the same order as the notes. They don't even mix it up on us. They're really being gingerly with us. All right. So log base b1, we're looking for this right here. Let's check the notes. Log base b1 is equal to 0. Okay. Log base b1, or log base b of 1 is equal to 0. And when we study the graphs a little bit more, that's going to make some additional sense to you. Maybe never total sense, but you'll see that more later. And we're just going to try to stay on track here and get not off too far off track here. So this is a log base b of b. Log base b of b, here's a log base b of b, and that is equal to 1. So we're going to mark that one. This is a log base b of b to the k right here. So we're looking at log base b of b to the k is equal to k. Some properties there that we're rolling through. This one is b to the log base b of k. So notice the b is being raised to this log base b. This is up in the power. What is this equal? Let's see if we can find it. Right here, b raised to the log base b of k equals k. So some identity properties we're rolling through. All right, convert the following to logarithmic form. Now, we understand this. This is an exponential curve setup here of a 2 raised to the power x. But what we have is equal to 5. This has a format we can follow. Let's see if we can find this in the notes. Here we go. So here we have a 2 to the power x is equal to 5. 2 to the power x is equal to 5. They're giving us the exact same one. The x comes down out front. So the x is out front. There's an equal sign. We're going to write the word log. And we're going to put what's in the base in this case now goes to the base of log. That goes in 2. And we're going to put the 5 straight down. And this is why we say log base 2, 5. Right? It's coming from this format where the base is actually going down into this position in this statement. So it's rearranging of a current statement we somewhat understand, maybe not as much as we should, but we do. And it's moving it into a new statement we really don't understand, but we can follow this format a couple of times in practice here. That's what we're trying to do in this lesson. All right, convert the following. So we knew that this is the base, right? So what we have here is a log base 2 in this case. We know that the x in the last one came out front and said equals, and the 6 came here into this position here. So we have x equals log base 2 of 6, or just 6. Convert the following. Let's do it again. The base goes into the log, so log base 2. There we go. The x is out front, equals, and the 11 goes here. And we're going to practice going back and forth. On this one, we stop right here. But basically speaking, if we were given this, we would be able to go back, move the 2 to here. This becomes the power of it. 2 to the power x equals 11 in this case, comes right here. All right, so we're going to go back and forth, just sort of understanding there's this conversion between these two formats. And that's enough for now to sort of get us started on logs light. Okay, so when you show up at Algebra 2 and you're like, yeah, I know what I've heard the word, I don't know everything about it. And that should be perfect for Algebra 2, because then they're going to start over again and teach more on logs. Algebra 1, the title of this is Algebra 1, Semester 2. It's the 4th unit, Exponential Functions, and it's the 5th lesson on Rules of Logs Practice. It's on CreatorMathcom under the Algebra 1 tab. Hope this helps.